Hello everyone, I prepared this video to show you how to use the interactive gallery of Quadric surfaces. Now click on the link and you will be sent to another website. The reason I include this interactive gallery for you is to visualize the Quadric surfaces and the intersection between the surface and plane. I'll leave you to read the introduction and instructions on how to use this gallery. Now let's look at one example. This is a typical sphere. Did you see the lines forming the surface? These lines are being called traces. The traces are the mesh lines that result when a surface is cut by a plane. For example, we have few parameters here. So this is actually the plane of x from -3 to 3, where you can adjust and you can see the intersection between the plane of x and the sphere surface. The orange color refers to the traces when the quadric surface of sphere being cut across by the plane of x, while the corresponding blue color is actually by the plane of y. So you can switch the view to see clearer. Whereas for the z is the dark blue color, where the intersection of the plane of z will cut across the sphere to give you a circle. Now let's move on to another example, elliptic paraboloid. This is the typical view of a parabola. When it is being cut across by a plane of x, you will realize that the intersection curve is actually a parabola or a quadratic curve. Whereas when the elliptic paraboloid is being cut across by the plane of y, you'll get the same parabola or the quadratic curve. Whereas when the elliptic paraboloid is being cut across by the plane of z, the intersection is actually a circle. Now this is the visualizations of the intersection between a plane and a quadric surface. What if you don't have this interactive gallery with you during the exam or the quiz? So how are you going to visualize the intersection between the plane and the surface? Now try to recall back the standard equations of the elliptic paraboloid. You have the standard equation x squared plus y squared equals to z. When the quadric surface is being cut across by a plane, which means that either one will be a constant. For example, if the elliptic paraboloid is being cut across by the plane of x equals to, let's say, 1. So you substitute the value of x equals to 1 and the equations that you will get will be y or z in terms of y squared. So it is actually the formula for a quadratic curves or a parabola. Now you swap the position again. Now the elliptic parabola is being cut across by the y, and you substitute the value of y as a constant and you will get the z equals to x squared. So this is another parabola in the z-x plane. When the elliptic parabola is being cut across by a z plane, you substitute the z with a constant and you end up will get a formula for the circle x squared plus y squared equals to a constant. So this is how you visualize without the interactive gallery. You just substitute the constant or the plane into the standard equations of the quadric surface to get the intersection. Now move on, I'd like to show you what will happen when the constant in front of the x squared and the y squared is being changed. Now this is the standard view of an elliptic paraboloid. It is symmetry in the x and y direction. But what if I change the coefficient in front of the x, and you see that actually the elliptic paraboloid is being distorted in some way. Now let's move back to the original position, and now I change the constant b. So you see now the elliptic paraboloid is being distorted in another way. So this is actually refers to the transformation of quadric surface. when the constant or the coefficient in front of the x squared, y squared, and z is being changed. What would happen if the coefficient of the a or b or both equals to 0? Try to play with the interactive gallery and you realize that when a equals to 0, which means that the x is 0, so the leftover will be z equals to y squared, which is a parabola or the quadratic curve. You see? If I change the constant of b to 0, I'll get another curve. In this time, z equals to x squared, which means that if we ignore the y-axis, you'll get a z equals to x squared parabola. Now, try to play with this interactive gallery for the rest of the quadric surfaces and compare with your calculations. So what would you get when you vary the constant, the AB constant, or when you cut across the quadric surface with a plane? Try to compare with your own manual calculation without the help from the interactive gallery and compare it. Or if you have some questions about this interactive gallery, you can post it in the comment sections. Thank you.